Good morning, everybody. Here we are again, working on Swiboe, the next generation text editor. And I actually have a couple of updates. I think last week on Friday we were working on Lua key maps, and I continued that work over the weekend a little bit. And even more importantly, I started looking into branding, and we have two very interesting updates here. So the first one is that I put down some money to find an icon for Swiboe. So I made a design contest on 99designs.de where designers can pitch in and provide suggestions for an icon, and the best one that I will pick will actually get 250 euros, and Swiboe will get a nice icon out of that, I hope. Um, so this branding activity now started, and the second one, which I want to show you guys, is my wife started designing the logo, or like not the logo, but the mascot. That is actually Bo. You can see here like it's Bo, and Bo is a Swi, and he will become the mascot for Swiboe. But there's still some work to be done before that is really done. Okay, and on the coding side, what happened there? So actually, I finished up the key mapping and integration of Lua over the weekend, and I wired it up to the terminal GUI. So basically, the terminal GUI will now read in our configuration.lua file here, and it contains some key mappings. And if you trigger those key mappings, it will actually execute the functions. So let me just show you that real quick. Whoa, that was wrong. We actually want Swiboe, not Vim. Here we go. So this is the terminal GUI, and it hasn't changed very much yet, so you can still look at all the files in the directory. But you can also now trigger the key bindings you set up in Lua. So for example here, when I press I, then it will run this function, and it just prints out like a variable here, like twice. And you can see how that actually messes up the terminal GUI because Rustbox, the GUI library we're using for interacting with the terminal, it doesn't like if you actually print something to standard out. That messes it up completely. So I actually opened a bug that we need some sort of debugging plugin, something that can connect to the server and that you can send some messages that it will just print. Ooh, I hear myself now. No, that's good. So silent. Yeah, and another one. So this shows off like a simple key binding with just an I, and this one shows off a so-called chord. So if you press two keys at the same time, so Control T, it will execute this function down there. Of course, Control T is already bound to like an internal key map which shows all the files. So let's try something else here. For example, Control I, right? So let's run that, and if I now press Control I, hopefully it would actually print a second command. And that's not quite working. Interesting. So it seems like this is still buggy. What definitely works is we can try so-called arpeggios. So for example, if I have AB and I start up the editor and I press AB, then it will actually print second command. So this is working. Cool. Cool. Okay, what do we want to work on today? So basically, what I want to do today is I want to look into passing the Lua client to the function that we call here. So basically, let's dream up what that should look like. For example, let's copy this here and make a new key map for the up button here for up. So what happens when we press the up button? Well, that's already wired up in the terminal GUI. So let's have a look at this one, how we do it right now. Here, that's what we do when we press the up button right now. So that is hard-coded in the Rust code right now, and of course nothing should be hard-coded, right? That should actually be a plugin function or a key map function. And so we would like to do it, like define it in Lua what actually happens. So this function should get something like a client, something that is able to actually call an RPC, and then we would like to do something like client call, and the function is GUI move buffer view move cursor. That's fine, right? and that actually takes a dictionary that we will convert into JSON, and that will be like it needs a cursor ID. For that we need something like Swiboe current cursor ID, something like that. Let me just finish the thought and say something about it. And the delta will be yeah, the line index will be -1 and the column index will actually be 0, right? So how does it look? Of course, that is not quite correct Lua syntax. That has to look like this, and this has to look like this. Here 2 and here 2. Great. So that's one of the advantages of Lua, that it's already looking very much like JSON. Just very minor changes need to be done to actually convert it to JSON. So basically, what does that do? If I press up on the keyboard, I would like that this function gets called and it receives a client. And the client is exactly like a client, like the client we already have in Rust code, in the sense that it should be able to call to RPC, like arbitrary RPC functions that are defined by other plugins, right? So if we now call this here, we will get something back like an RPC, and let is not the correct keyword, it's actually local. And with this RPC, we can actually decide what we want to do, and in this case, we would probably wait for it to terminate. And maybe we would also need to like check for success, something like that. And this one is still a little questionable, right? There can be multiple cursors in Swiboe at any point in time. Think about like collaborative editing or multiple cursors that you have, like just yourself, like a single user might have multiple cursors too. And inside of the GUI, we need to know which cursor is currently active, and somehow we need to surface that to this particular function. So for now, I would probably just ignore that and say no com. For now, we move any cursor, but we need to expose which cursor should be moved somehow for this method, right? Okay. So I think that looks pretty reasonable. It looks very powerful. So basically what we're saying is that with any key map that we can define already, we can execute a function that can call arbitrary RPCs and then do arbitrary logic on them and their result. So I really like that. However, this here is a little like that's work. That's actually something that we need to look into. Basically what we would like to do is we would like to wrap a class that we already have in Rust and make it available to Lua somehow. And that is actually not straightforward, and that is what we'll get started on today. But I don't think that we actually can finish that today. And I guess there will also be a lot of Googling today, because I'm not quite sure how that actually works. So, where were we? This is the Rust file that we're working on. Here we already have our Lua map function, and basically down here we actually call this mapping, right? So basically here we get the key map handler, and then we insert the mapping that we constructed up here. And once this is actually called, this mapping, then we basically say we like prepare the Lua function call. So that what that does is it pushes the Lua function onto the Lua stack, and then we just call it. And I will actually change a little bit, and will look something like func prepare call, and then here it will be something like push thin client or something like this. So we actually would like to make a thin client available to Lua as one argument, and then we'd like to call this with this one argument, and we probably, are we interested in a return code? Maybe not for now. Okay, so we need a thin client here, And how did we get a thin client? Well, right now inside of this Lua stuff, we only have the config file runner. So the easiest would probably be to just put a thin client in the config file runner that we can make available for this Lua function call. Though we actually, we cannot actually share that thin client. We have to clone it. But so what? Then we clone it. Config file runner is defined here. So we would like to have here a just let's call it client. Oh yeah, we're using a thin client here because there can only be one client, and a client is defined as something that can handle RPCs and something that can call other RPCs. And a thin client is something that can only call other RPCs but cannot handle any incoming RPCs. So this is actually what we want here. Like, is it really called thin client? Let's have a look. Client.rs and client.rs. It's not called thin client. Wrong file. There it is. It's actually called thin client. Perfect. Perfect. Okay, so we need a thin client here, and the config file runner actually on creation it needs that thin client to be passed in. Thin client, thin client. Perfect. And it takes ownership of that. That is fine too. So we pass it by value. And here we call it, well, let's be consistent and call it thin client everywhere. Okay. So that wasn't too bad. So up here we actually, like here we need a thin client clone, right? Because we cannot actually, like this callback needs to get its own thin client. Otherwise it will just like not work properly. Right, because we never know when this function gets called, and thin clients cannot be actually shared between threads, and we have no guarantees on which thread this function actually gets called. So we have to give it its own thin client. So we have the config file runner here already, and then we have here the thin client, and then we call clone on that. And hopefully clone is already supported. Yes, thin client clone. What does it do? It's actually interesting. It's actually like cloning some channel and then wraps them in a mutex. That feels pretty clunky, but for now that seems to be working. Okay. Okay, so I think this is actually looking reasonable. Of course, this net needs the thin client clone to actually push it. And we need to implement this method on prepare call. So like Lua function actually, you call prepare call and then you get a prepare call object back, which is a kind of a builder for a Lua function call. And this actually needs to support to push a thin client. And does it take ownership of the thin client? I don't think it needs to, but it needs to, well, it needs to be mutable itself, and it also needs to take a mutable reference to that thin client. Pretty sure about that. Right, and that should probably also return something. Yeah, of course, it's a builder, so it has to return itself, right? And then it actually will also consume itself, right? Ah, perfect, like so. Like so. Right, and now begins the interesting part. I have no real idea how that looks, actually. So basically, we have a thin client that we have as a Rust tool, like a Rust class, and we actually now need to provide it to Lua as a Lua class. And for that, I think, so basically, get the thin client to Lua. And for that, we need something that is called a, basically we would like to tell Lua this is something that we're interested in, and please keep track of us for us from that one. And then also we'd like to have that thing. We would like to have that thing to have some functions that we can actually call on that. And I'm not quite sure how that is actually looking. So we need something like a meta table, right? So we will create a new meta table, and then we will populate it actually with a bunch of functions, and then we have to like push some sort of user data and make that available, be associated with this meta table. Basically, like the flow will be something like push user data, which will be like self, like let mutable Lua state. There will be self Lua function Lua state. And here we will have something like Lua state push user data, the thin client. And then we will do something like Lua state get meta table, and that will be will probably be called thin client. Of course, all of this code is not going to work, right? That's just more or less how the flow would look. And then we will have something like Lua state associate meta table, and then basically the thin client will get this meta table attached to it, and that should be it. That should be all that is needed to actually push that here. And where we actually create our Lua state, that is in the config file runner, at the very beginning of the config file runner. Here, where we like do something like a Lua state new lib and set global and stuff like that. Here we actually would like to create the meta table for all of our wrapped classes, right? So in this case, we only would like one meta table. So state new meta table for the thin client, something like that. And then we need to push the various methods of the thin client. Wow. So let's open a new tab here. And this one actually goes into the Lua. So I'm looking for the checkout that I have from the Lua library that we're using. Rust, Lua, sure, whichever. This one should be fine. And here there will be a state. Cool. And here there must be something like a meta table, right? How do you create a meta table? New users, blah. New user data. That seems like something that I want later, maybe. Get meta table. Not quite, not quite. set meta table, that's what we need later to actually associate our user data with that. Here, new meta table. And so that already seems correct. Like, it just takes a name and then we have it. Cool. Cool. And how does it continue to work though? I mean, if we now we have to put some methods in there. How do I actually like put a method on the stack? So like push fn or something. Maps to Lua push C function. And that takes a function, and a function is a Lua C function. Cool. So that seems like we can simply put basically like we create a meta table and then we like push a string and that is like some function, right? We just try to associate any function, like some function with our thin client and hope that this will work. So we push a C, now we need to push a function and this function will be called Lua some function. And that has to probably look exactly like this one. Lua some function, and that will just print a line and say called Lua some function. Perfect. So far, so good. So we have the table, we push the key, we push the value, and now we say state. Ooh, guys, my computer starts overheating already. Okay. I guess we have to call it a day for now. My computer is no longer cooperating. So basically, what we did so far, like, of course, nothing here compiles, but we started to outline that. We actually, like, we are now constructing a meta table, which is the table of functions that thin client will eventually support. And now we're trying to write some stupid function just to make sure that everything is working according to plan. And so we create the meta table here, and then later up in the client, we actually have to try to call the meta table. Yeah, I think that's where I need to stop for today. I'm not sure if I can actually make progress on that today, but otherwise we will just continue here tomorrow. Talk to you guys later.